Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of rational function. So as per the problem, determine the intercepts, asymptotes, and end behaviors for function f at x equals 5x minus 3 over 4x plus 9. Then sketch the function and find its domain and range. In this problem, we are given a rational function and we have to find its key features. Let's start with the intercepts. We'll find the x-intercept first. For x-intercept, we should sub in the function value as 0 in the given function equation and solve for x. Next, we can cross multiply the denominator to the left side. 0 times 4x plus 9 is equal to 0. We have to isolate x in this equation. We should move negative 3 to the left side of the equation. Next, we can divide both sides by 5. I get x equals 3 over 5 or 0.6. We can write this x-intercept as an ordered pair as 0.6, 0 or 3 over 5, 0. Next, we can find the y-intercept. For y-intercept, we should sub in x as 0 in the given function equation. Five times 0 is 0. 0 minus 3 is negative 3. 4 times 0 is 0. 0 plus 9 is 9. We can reduce this fraction to negative 1 over 3. We can write this y-intercept as an ordered pair as 0, negative 1 over 3. Next, we can find the horizontal asymptote. In this rational function, the degree of the numerator is 1 because of the x term. The degree of the denominator is also 1 because of the x term in the denominator. The equation of the horizontal asymptote will be equal to the ratios of the coefficients of the x terms. I get y equals 5 over 4 or 1.25. There is a very important concept we need to understand and memorize to find the horizontal asymptote for a rational function. Next, we can find the vertical asymptote. For vertical asymptote, we should set the denominator equal to 0 and solve for x. I get x equals negative 9 over 4 or negative 2.25. So this is the equation of the vertical asymptote. Next, we can find the end behaviors for the asymptotes. Let's start with the horizontal asymptote. For horizontal asymptote, the end behavior can be written as we have to find whether the graph of this function approaches the horizontal asymptote from above or below on the left side and the right side of the x-axis. Let's start with a check on the left side. We should use a big negative number for x in the given function equation. We can sub in x as -100. In the numerator, 5 times -100 is -500, -500 minus 3 is -503. In the denominator, 4 times -100 is -400, plus 9 is -391. The value of this fraction is 1.286. This value is greater than 5 over 4 or 1.25. That means the graph of the function approaches the horizontal asymptote on the left side from above. Now we can do the test on the right side. We should use a big positive number. We can sub in x as 100. In the numerator, 5 times 100 is 500. 500 minus 3 is 497. In the denominator, 4 times 100 is 400. 400 plus 9 is 409. The value of this fraction is less than 1.25. That means on the right side of the x-axis, the graph of the function approaches the horizontal asymptote from below. So this is the end behavior for the horizontal asymptote. Now we can find the end behavior for the vertical asymptote. We have to find whether the graph of the function approaches positive or negative infinity on the left side and the right side of this vertical asymptote. Let's start with a check on the left side. On the left side, we should use a value very close to -9 over 4 or -2.25, but on the left side of -9 over 4. We can use the value -2.5. We can sub in x as -2.5 in the given function equation. The value of the expression in the numerator is negative 15.5. The value of the expression in the denominator is negative 1. The overall value is positive. That means on the left side of the vertical asymptote, the graph approaches positive infinity. Next, we can do the check. For the right side of the vertical asymptote, we can use the x value, negative 2. The value of the expression in the numerator is negative 13. The value of the expression in the denominator is 1. So the overall value is negative. That means on the right side of the vertical asymptote, the graph of the function approaches negative infinity. So these are the end behaviors for the asymptotes. Now we can sketch the function. We can start by plotting the intercepts. The x-intercept is at 3 over 5 or 0.6. The y-intercept is at negative 1 over 3. The horizontal asymptote is at 5 over 4 or 1.25. The vertical asymptote is at negative 9 over 4 or negative 2.25. Now we can show the end behaviors. On the left side of the x-axis, the graph approaches the horizontal asymptote from above. On the right side, the graph approaches the horizontal asymptote from below. On the left side of the vertical asymptote, the graph approaches positive infinity. And on the right side, it approaches negative infinity. Now we can join the end behaviors. So this can be the sketch of this rational function. Now we can find its domain and range. Domain is set of all possible x values for a function. In this case, the restriction on the domain is the vertical asymptote, which is at negative 9 over 4. So the domain can be written as in interval notation, the domain can be written as next we can write the range. Range is set of all possible y values for a function. In this case, the restriction on the range will be the horizontal asymptote y equals 5 over 4 or 1.25. So we can write the range as we can write the range in interval notation as So this should be the range for this rational function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.